Hello everyone. So let us try to solve this question which is written over here. So this can be solved by using or applying our first law of thermodynamics to an open system, right? So let us read it. So it's telling that there is on what? There is a turbine, right? So in the turbine of a gas unit, the gases flow through the turbine is this much amount of mass flow rate, right? Okay, so this is m dot which is given to us as 17 kg per second. Okay, the power developed by the turbine is 14,000 kilowatt. Okay, 14000 kilowatt. This is the power which we are getting from the turbine, right? So obviously it is work. The enthalpies of the gases at the inlet and outlet are given to us. So at inlet it is 1200 kilojoule per kg, and outlet it is 360 kilojoule per kg. Okay, and the velocity of the gases at inlet and outlet also given to us. It is 60 meter per second and 150 meter per second respectively. So we need to calculate the rate at which, obviously in kilowatt, the heat rejected from the turbine. Okay, so we need to find out the rate at which our heat is getting rejected from the gas turbine, right? So let me try to draw this gas turbine over here. So this is the layout of our turbine. So in our turbine, definitely our gas is expanded. So volume of the gases increases. So the inlet section will be over here. So inlet section will be over here, and this will be my outlet section, right? So this is the inlet section, and this is the outlet section. Okay. So I can write this as section 1 and this as section 2, right? So at inlet, we are given with H1. H1 is given to us as 1200 kilojoule per kg, and H2 it is given to us as 360 kilojoule per kg, right? And mass flow rate m dot is given to us as 17 kg per second, and W. Okay, so W dot, we can say this is what this is equal to 14000 kilowatt, right? And when, okay, what else given? We are also given with the velocity data, that is v1 is equal to 60 meter per second, and v2 is given to us as 150 meter per second, right? So inlet and outlet velocities are this much, and we need to find out what this q dot, right? We need to find out this one. Okay, so our air or gas which is taking entry, it will be moving into this what, this turbine. So it will be having some kinetic energy, as this is given the velocity data, and it will be going with some kinetic energy as v2 is also given. Okay, and there is no data related to potential energy, so we can neglect the change in potential energy, right? So potential energy change is being neglected in the question, and heat transfer rate we have to find out. So let us use our steady flow energy equation. Okay, so according to steady flow energy equation, you can write that is m dot times m dot h1 plus b1 square by 2 plus gz1 plus this is q dot. This will be equal to same m dot times h2 plus v2 square by 2 plus gz2 plus w, right? W dot. So here we can neglect these two values, that is potential energy change has been neglected. Okay, so now we need to find out this value, that is q dot. Okay, so let us try to find out. So what is given? So m dot is given, h1 is given, v1 is given. Here also m dot is known, h2 is known, v2 is also known. So simply we need to plug in the values of given data, and w is also given, right? So w dot is also given. So simply we have to plug in those values which are given to us, and we need to find out the value of Q dot. Okay. So another thing, if we'll be looking into over here, this H1, this is given in terms of kilojoule per kg, right? And we know this is V1 square by 2. This is really is in the terms of joule per kg. So we have to convert this joule per kg into what? Kilojoule per kg. So to do that, we have to add triple zero over here, right? I hope it is understandable. So let me use another color so that it will be little clear. So we'll be adding or multiplying 1000 in the denominator of this is kinetic energy term. Okay. Similarly, I will be having triple zero over here, right? So why I am doing this? Simply to make our unit. Okay. So a constant unit we have to keep. So as H1 term is in kilojoule per kg, and here also this heat transfer we have to find out in terms of kilowatt, and this work data which is given to us as in terms of kilowatt also. So we need to convert this kinetic energy term in terms of kilojoule per kg. Okay, that's why we have to multiply in the denominator of this kinetic energy term by 1000, right? So now simply we have to plug in the values which are given to us. So m dot, we have to find out q dot, right? So q dot will be equal to what? This will be m dot, I'm writing h2 minus h1. Okay, so I'm taking all this term to right hand side, right? So m whole into h2 minus h1, and there will be plus. Okay, so let me clear this question. Okay, so this is h2 minus h1 plus v2 square minus v1 square divided by 2000, and there will be plus w dot. Okay, so w dot data is given to us as 14000, right? This is 14000. Okay, so m dot is given to us as 17 kilo kg per second. Okay, and h2 is given to us as how much? That is 360, and h1 is your 1200. Okay, so h2 is 360, 360 minus 1200 plus, so v2 square minus v1 square. So v2 square is 150, I think. So okay, so v2 is 150 and v1 is 60. So 150 square minus 60 square divided by 2000 plus this 14000, right? I hope I have plugged in all these data correctly. Okay, so let me calculate this value. So this is 17 multiplied by this term, that is 360 minus 1200 plus there is 150 square minus 60 square divided by 2, right? And I'll be adding with 14000. So I'm getting minus, so let me write down that over here. So I'm getting minus 119.35. So obviously here I'll be getting this term in terms of kilowatt. Okay, so q dot, this is the obviously minus sign, simply indicating that our heat is getting rejected from the system, right? And we are asked to find out what we are asked to find out. We are asked to find out the calculate rate at which heat is rejected from the turbine. Okay, so we need to answer this one. Okay, so here minus sign is indicating that our heat is getting rejected from the system. So we can say q dot will be equal to minus 119.35 kilowatt. And if this is the heat interaction value, okay, and it is asking to say how much will be the heat rejection. So I can say q dot will be equal to 119.35 kilowatt, and this is rejected heat from turbine. Okay, hope was understandable. Okay, try to solve many more questions related to this. Thank you.